Okay, so this question is the last question on this for this set of notes. It's looking at the 2005 AP exam. And again, it's a differential equation, and it asks for a slope field here. So what we're going to do is we're just going to take those x and y coordinates, plug them into our differential equation to find slope segments. So when x is 1, y is 2, we get a slope of 0. Okay, when x is 1, y is 1, we get a slope of 1. Okay, when x is 1, y is negative 1, we get a slope of positive 3. Okay, we have points here, x is 0, y is 2, so we get a slope of negative 2. X is 0, y is 1, we get a slope of negative 1. Okay, here we have a slope of positive 1. Okay, so there's our slope field for those 6 points indicated. All we're doing is plugging in. Again, the slope field doesn't have enough points to give us a good indication what the solution to the differential equation looks like. For part B here, it says d squared y over dx squared. Find the second derivative, okay, and determine the concavity for all the solution curves for a given differential equation in quadrant 1. So quadrant 2. So quadrant 2 would be negative x, positive y. That's quadrant 2. So I'm just going to make a note of that. The second derivative was, I take the first derivative, 2x minus y, and differentiate it. So I take d by dx of, d squared y over d squared x is the derivative of 2x minus y, so it's going to be 2 minus y prime. Okay, that's right. Okay, so that's going to be my second derivative. I should express that second derivative in terms of x and y, so I can replace that y prime. Okay, so I'm just going to highlight that. My y prime here can be replaced with this expression. Okay, so 2x minus y. So I'm going to go ahead and do that. 2x minus y, so it's going to equal 2 minus 2x minus y. Okay, so my second derivative is essentially y plus 2 minus 2x. Okay, so that's the equation of my second derivative. And it says find the solution to all the curves, the concavity for all the curves in quadrant 1. What that means, if I plug in a negative x and a positive y, so that's going to be all positive. So the d squared y over dx squared in quadrant 2 is going to be always positive, so we're going to have positive concavity. Okay, so that's part B. Part C says f of x be a particular solution to the differential equation with this initial condition. Okay, so let's first of all solve for f of x. Oh, we can't. Okay, so we can't find that. So it says, does f have a relative minimum or relative maximum, or neither x equals 2? Well, if it's a relative minimum or relative maximum, that means that the derivative must equal to 0 at some point. Okay, so we can't solve this because it's not, this is the reason why, make sure you understand why we can't solve this differential equation, because we cannot separate x and y by times and divide. Okay, so we can't separate it to solve this, so we can't actually solve that differential equation, but we can find the derivative. Okay, the derivative is, or the slope needs to be equal to 0 at that point. So if I plug in, it's going to be 2 times x minus y. Okay, that's my x and y coordinate. And when I do that, if I have an initial condition of that, x and y, that's not going to be equal to 3. Okay, so at x equals 2, my derivative is not equal to 0. It's equal to 1. I have a slope of 1 through that point. So no, slope is not equal to 0. X equals 2 is not equal to 0. Therefore, no max or min. Okay. Okay, so there's our justification.